Hello and welcome to part 2 of our walkthrough through exam style questions based on those from the 2020 Level 2 Calculus exam. We are now on question 2a, which is to write as a single logarithm in its simplest form the expression log 7a squared plus log 4 minus log 2a. So this requires the log rule that when you add two logs together, you can write those as one single log if you multiply the arguments inside them. So log a plus log b equals log a times b. And when we're subtracting logs, you can do something similar, but you write as a over b. So if the logs are subtracted, you divide the arguments inside them. So this only works if the bases of the logs are the same, which in our case they are. So you'll notice there's no base written, so a base would be a little number down here. So there's no number written here, which means these are all logs of base 10, otherwise known as common logs, which are the ones that you can do in your calculator using the log button. So these all have the same bases, so that means we can apply these rules. So the best way to deal with this is to break it up and do the addition first, then we'll do the subtraction afterwards. So we've got log 7a squared plus log 4. So using that first rule, we can write those as a single log and multiply the arguments inside them. So 7a squared times 4 would be 28a squared. And then minus log 2a. So the next one is subtraction. So to subtract logs, we write them as a single log. We divide the arguments inside them. So 28a squared divided by 2a. Well, 28 divided by 2 is 14. A squared divided by a is a. So that leaves us with 14a. And that is the answer. We have written that as a single logarithm. We can't simplify that any further. So that's that question done, and that is an achieved question. Okay, on to part B. So two parts to part B. First one is to solve the equation log base v of 64 equals 6. So the unknown is v, which is the base in the log. So it's not actually any use as it's written like that. We can't solve this as it's written. You also can't solve these ones on your graphics calculator because calculators can't do logs with bases other than 10. So common log or e and natural log. So if we can't do it on the calculator and it's not any use to us as it is, we need to rewrite it. And this time we're going to use a different log formula, but this one is on your formula sheet that you will get in the exam. So I'll bring that across so you can see it. So we see here we've got 3 different logarithm rules. We are going to use the first one. So this one here. If y equals b to the power of x, then x equals log base b of y. So ours looks like this one at the moment. But we want it to look like the other one. So let's rewrite that using that formula. So I'll rewrite it so you can still see. So y equals b to the power of x, then x equals log base b of y. So it's about just putting things into the right place. So b is the base in the log, so that's v for us. The argument in the log is y, so that's 64 for us. So that's going to go on the other side. And then x, so the answer to the log question is x. So that is the power. So that's 6. So this is now saying 64 equals something to the power of 6. Now, the nature of powers is that they get very big very quickly, so v must be a fairly small number. So for example, if it was 10, the answer would be 1,000,000. So it must be less than 10. So we can answer this though by doing a sixth root. It's kind of like a square root, but 6 rather than 2. So if we do the sixth root of v to the power 6, that will equal the sixth root of 64. So it'll equal v. And this bit you can now do on your calculator. So go 6 and then shift and then the exponent button, so doing x square root. So sixth root of 64 is 2. So v must equal 2. You can check your answer by going 2 to the power 6 and you should get 64. Yep, you do. So v must equal 2, and that is the answer, and that is also an achieved question. Okay, on to part 2, more logs. So we have got to solve this equation here. Log 4 of 3x to the power of 4 minus log 4 of 6x squared equals 6. So you'll notice we've got bases of 4 again. So again, you won't be able to do this on your calculator without rewriting it. And you'll also notice that in the previous one, I didn't use brackets around the 64. In this one I have. That was just to show you that you don't have to. It's sometimes a good idea to, so you know what the argument in the log function is, but it's not essential. Okay, so as it is, there's not a lot we can do with this. So we're going to have to rewrite it in some way. So you'll notice that the bases in the log are both the same. So that means we can write these as a single log using similar techniques to what we used in question A. So using these two rules here. So these are taken away, these are subtracting, so we can write these as a single log. So the base stays the same. So we have to divide the arguments. So 3x to the power of 4 over, I'm writing it this time because it's just a little bit more complicated than the previous one. If in doubt, it's always best to write things out, to take it one step at a time. So we'll simplify that now. So 3 divided by 6 would be 1/2. X to the power of 4 divided by x squared would be x squared. So this would be log 4 of half x squared, or you could write that as x squared over 2. That would be the same thing. I'm going to keep using brackets just to make it clear what is inside the log, which is the 1/2 x squared. So again, still no, we can't do too much with this as it is. So again, we're going to want to rewrite this. And we'll use the same rule as we used in this one in the previous question to do this. So I'll rewrite the log rule. So if y equals b to the power of x, then x equals log base b of y. So yeah, we've got the log form, we've got this form, but we want it like this, because as it is, we can't really do much with it. So again, it's just making sure everything matches into the correct spot. So the answer to the log are 6, that is the power. The base in the log is the base. So our power will be 6 and our base will be 4. So we're going to have 4 to the power of 6 equals y, what's inside the log. So for us, that is half x squared. So now it looks like y equal b to the power of x. I did write it backwards, but that's fine. Doesn't matter which way around we go. All right, so you'll notice that on the left-hand side, that's all numbers now, 4 to the power of 6. So we can work that out. 4 to the power of 6 is 4,096. That is definitely one for the calculator. Equals half x squared. So now it's a process of getting x by itself. So if we divide both sides by a half, that will get the half away from the x squared. And that gives us 8,192 as x squared. So now we can square root both sides. I've left that in my calculator so I can just go square root of the answer, which is 90.5097. So it will be plus or minus that, and whenever you square a number, it's always positive. So negative 90.5097 squared and positive 90.507 squared would make 8,192. However, in a log, the numbers have to be positive. So we just need to check if that would work. Well, it would, because on the x's, we've got even powers, 2 and 4. So those x answers would always be positive. Because anything to the power of 2 or 4 will always come out positive, whether it's positive or negative. So x equals, we'll just round that to 90.5, I think. Either negative 90.5 or x equals positive 90.5. So those are the solutions, and that is an excellence question. So for achieved, you have combined the logs. So, and simplify it, so that's achieved. For merit, you have found an answer for x. And for excellence, if there was a negative solution to be discounted, so yeah, I've explained why that's not the case in these ones, but if you did have to discount the negative solution, that would be the difference between merit and excellence, or in this case, the explanation that x can be negative. X can be negative because 3x to the power of 4 and 6x squared will always give positive answers. So that's why we don't discount the negative solution. Or if you also, when you square rooted it, if you just got 90.5 with no other explanation, that would also be a merit. That full answer is an excellence. Okay, on to question C. Solve 4x minus 3 over x plus 2 minus x plus 5 over 2x minus 1 equals 3. Now, quite a lot going on there. So the key to this is understanding known fractions. And specifically that if you want to add or subtract fractions, they have to have the same denominators. Now, as you can tell, these don't. So we need to make the denominators the same. And the way to do that is to multiply each denominator by the denominator of the other fraction. So for 4x minus 3 over x plus 2, we are going to times this by 2x minus 1, the denominator of the other fraction. And for x over 5 plus 5 over 2x minus 1, we're going to times that by x plus 2, the denominator of the other fraction. Now, I'm only going to do these one at a time, though. We don't want to overcomplicate things. If you do too many steps at once, that's usually where mistakes happen. Okay, so, and we will go 4x minus 3. So again, we're going to times that by 2x minus 1. So again, only doing one thing at a time. So I'm not actually multiplying them yet, writing it in factorized form. And now we're going to multiply the other one. So again, whatever you multiply the bottom by, you've got to multiply the top by the same thing. So for the second fraction, I have multiplied 2x minus 1 times by the other denominator, so x plus 2. So that's why I'm timesing the top by x plus 2 as well. This keeps the size of the fraction the same. So again, just doing one thing at a time. So I've just written those in factorized form. Now we will expand. So starting with the first one, 4x times 2x is 8x squared. Then 4x times 1 is minus 4x. Negative 3 times 2x is negative 6x, and negative 3 times negative 1 is positive 3. At the bottom, x times 2x is 2x squared. X times negative 1 is negative x. 2 times 2x is 4x. 2 times negative 1 is minus 2. Take away now for the other one. So because the denominators are the same, they will expand to the same thing. There we go. And then top, so x times x is x squared. X times 2 is 2x, 5 times x is 5x, and 5 times 2 is 10. So I don't want to subtract anything just yet. We're going to keep the fractions separate for now and just simplify them as much as we can. So at the top of the first one, we can do negative 4x take away 6x. They are like terms because they're both x to the power of 1. So we can simplify that to 8x squared minus 10x plus 3. And then at the bottom, that will simplify to 2x squared plus 3x minus 2. The other one, again, the denominator will make the same thing because they are the same. And at the top, that will be x squared plus 7x plus 10. This all equals 3. So by doing the multiplication and then simplifying, this is going to make the next step easier where we write them as one single fraction. Because you could have done it in a different order. You could have written it as a single fraction first and then expanded and simplified and stuff. That'd be a bit more complicated. I think it's easier to do it this way. So when you subtract or add fractions, you only add or subtract the numerators, so the numbers at the top. We don't do anything with the denominators. I have not left myself enough room. Let's move that out of the way. Underestimated how much working out there is in this question. Okay, so we will go 8x squared minus 10x plus 3. Now I've got to be careful here. I'm going to do this because we've got to make sure we do the negative of everything that is in this second fraction. Now in this case everything's positive, so they'll all just become negative, but sometimes you have a mixture and then you've got to be careful with double negatives and things. And at the bottom, so nothing happens with the denominator, so this is all just over 2x squared plus 3x minus 2. And again, the other side all equals 3. So I'll simplify the top as much as I can and then we'll just see where we are at. So again, just one thing at a time. So that will be minus x squared minus 7x minus 10. 2x squared plus 3x minus 2 equals 3. So we'll simplify the numerator now as much as we can. So just need to identify the like terms. So we've got 8x squared, we've got minus x squared. So that would be 7x squared. We've got minus 10x minus 7x, and that would be minus 17x. And then we have got 3 and minus 10, so that is negative 7, all over 2x squared plus 3x minus 2 equals 3. Okay, well, it looks a lot tidier now, but we need to solve for x, and we have not got an answer for x yet, so we're going to have to keep going. So it looks like we will end up with a quadratic equation from doing this. So a quadratic equation, we want it to equal 0 before we can solve it. So need to do something so that we can make it equal 0. So what I'm going to do now is multiply by the denominator of the fraction, 2x squared plus 3x minus 2. So what that's going to do is remove that and take it all to the other side. So 7x squared minus 17x minus 7. And again, always use brackets when working with lots of stuff. So all of that needs to get multiplied by 3. So let's deal with that. 3 times 2x squared is 6x squared. 3 times 3x is 9x. And 3 times negative 2 is negative 6. Okay, let's rearrange and make this equal to 0 now. So we'll take all those things to the other side. So since we're just moving things to the other side, you might be wondering why I took the 2x squared plus 3x minus 2 to the right if I'm just going to move it all back to the left. Well, we notice now we've got no fractions, and that's good. Fractions are not your friend when trying to solve something. So by multiplying, we've removed the fraction. Now we're just going to be adding and subtracting. So everything will be fine. We won't have any fractions, and that is good. So we'll take away 6x squared from 7x squared, which is x squared. Negative 17x take away 9x, be negative 26x. And then negative 7, we're going to be doing plus 6. So that will be minus 1 equals 0. So now we've got it into this form, we are going to be able to solve it. Now you can check if you are able to do the AM method to factorize this and then solve it that way. In this case, this is not going to factorize. So we have two options. We can use the quadratic formula, which is on your resource sheet. So that is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Or we can use the graphics calculator to answer this for us. I'll do both ways. So I'll do the calculator first, because that way I'll know then if my answer is right when I do the quadratic formula. In terms of the exam, if you got this far, that would be fine. You don't then need to show how you solved it. They're more interested in your algebraic working to get to this stage. So if you then just went, okay, the answer is this, that would be fine. You would still get the full grade, which for this question is a merit. So on my graphics calculator, I'm going to go to the equation function and then F2 for polynomial. And then degree 2, because this is a quadratic. So it's 1x squared minus 26x minus 1. Okay, so that has given me answers of x equals negative 0.0384 and x equals 26.038. You always need to use your arrows to go and check the answers and just make sure, because the calculator doesn't round them for you. So just use your arrows to flick between the two solutions and check that you're going to round it correctly. Okay, let's use the quadratic formula. So I'm just going to label, so A is going to be 1 here, B is going to be negative 26, and C is negative 1. Okay, so x equals negative b, which is itself a negative, so we've got a double negative, which is always fun, plus or minus the square root of b squared minus 4a, which is 1, c, which is negative 1. The extra pair of brackets here is for when we put this into the calculator, over 2a, which is 1. Okay, let's simplify this a little bit. I like to simplify before I put it in the calculator. Just so then what I'm entering in the calculator is a bit simpler and just makes you a bit more confident that what you've got is correct. So 26 squared, or negative 26 squared, 676, minus 4 times negative 1, which would be plus 4. That's all over 2. So x equals 26 plus or minus the square root of 680 over 2. So we can now put that in a calculator. So we'll go 26 plus square root 680, and divide that by 2, which gives us 26.038, which you'll see we also got from the calculator. So that's a good sign. And then we'll just go back and change that positive to a negative. And we get negative 0.0384, which we also got from the calculator. It was just a lot quicker on the calculator, but that is how you would use the quadratic formula to get those answers. So as I mentioned before, this is a merit question. For an achieved on this, you need to get the fractions into a common denominator. So that was a long time ago we did that. So getting to around about here for achieved, and all the way down here for merit. Again, you don't have to do the quadratic formula. It's absolutely fine to use your graphics calculator to get the answers. You will still get a merit. All right, that's that one done. On to part D, which is the final part of question 2. Consider two parabolas. Parabola 1 is given by the formula y equals ax squared plus bx plus c, and parabola 2 is given by y equals dx squared plus ex plus c, where a, b, c, d, and e are constants, so they're numbers. Use algebra to determine the restrictions on the values of a, b, c, d, and e that would ensure the parabolas meet at 2 unique points. So that means we would get 2 solutions, in other words. 2 unique solutions specifically. So when we solve this, we should get solutions that are 2 different numbers. So the question is asking about the 2 parabolas meeting at unique points. So if the parabolas are meeting, they are intersecting. So if we were to draw this on a set of axes, just to sort of show you what that means. So we could have any 2 parabolas, doesn't matter exactly what they look like. So if they're going to meet at 2 unique places, they are crossing each other or intersecting. So for those particular x values, their y values are also the same. They're in the same place at the same time. So what that means is their 2 equations are giving you the same answer. So what that means is that the equation for the first one is equal to the equation for the second one. Now notice we've got plus c on both sides. So if we take away c from both sides, what that's going to do is just cancel those out. So ax squared plus bx therefore equals dx squared plus ex. So again, a, b, and we don't have c anymore, but a, b, d, and e are numbers. So this will be a quadratic equation, the answer to this, so long as a and d are not the same number. So it's a quadratic, so it needs to equal 0 to solve it. So we will get everything onto one side. So I'll take away dx squared and ex from the right hand side. So we'll go ax squared plus bx minus dx squared minus ex equals 0. I'll simplify this. So we'll write the 2x squared terms as 1. So that would be a minus dx squared, and then plus b minus e x. So that equals 0. Okay, so you might be thinking, well, how is this helpful? We can't find an answer because we don't know what a or d or b or e are. But that's not exactly what the question is asking. It's asking to find a restriction on x. So our answer is going to be in terms of a and d and b and e. They're all still going to be in our answer. So if we were to factorize this, both of these things have a common factor of x. So this and this, you see they've both got x's in. So I can factorize this a little bit. Still all equaling to 0. So again, doesn't necessarily look helpful, but what you just need to imagine is that a and d and b and e are numbers that you know. So then it would look something a bit like if you had this orange equation over here. It looks a lot like that. Because if you knew what a and b and d and e were, you could simplify all that down and you just have a number times x plus a number, just like this orange equation. So in this orange equation, so we've got x bracket x plus 3 bracket equals 0. Our solutions would be 0 or -3. Because our equation needs to equal 0. So if the outside x was 0, wouldn't matter that you'd have 3 inside when you do 0 plus 3, because again, times by 0, so it's 0. Likewise, if x was -3, the brackets would give you 0, and then doesn't matter that it's -3 on the outside, it's going to get times by 0, giving us an answer of 0. So this one, our blue equation that we've got, is going to be along similar lines. One solution is that x equals 0. So because then this outside one would be 0. Then it doesn't matter what's inside because it's going to get times by 0, and anything times 0 is 0. Or the inside has to be 0. So if we rearrange this to solve for x, so we'd have a minus d times x. Let's just expand those brackets. So plus b minus e equals 0. So we'll take, first of all, e to the other side. And then we will take away b. So e take away b. And now to get x by itself, divide by the bracket, so a minus d. So that means on the other side we've got e minus b over a minus d. So that is our other solution. So let's put all this together into our answer. So there will always be one solution when x is 0. There will always be one solution when x equals 0. There will also be a solution where x equals e minus b over a minus d, so long as e minus b doesn't give you 0. Because if the top made 0, you would just get an answer of 0, and then it would be the same as the other solution. It wouldn't be unique. So there will be a second solution. So long as, well, first of all, so the one we just said, so long as e is not equal to b, otherwise e minus b over a minus d equals 0. And then again, that would just be the same solution. And so long as a does not equal d as well. Because if a and d are equal, you'll get a denominator of 0, which will mean the solution is undefined because you cannot divide by 0. So if a and b and d and e meet those two criteria, then those parabolas will intersect at two unique points, and therefore there'll be two unique solutions. Okay, so let's go through the marking. So for achieved, you have set up the simultaneous equation. So that is here. For merit, solving the quadratic correctly, but does not draw conclusions from the solution. So that is getting down to here. So you see you've got the two solutions, x equals 0 and x equals e minus b over a minus d. And then for excellence, you have got the full answer. So this is actually worth two excellence grades. We've got T1 or T2. For T1, correct working leading to one of the constraints clearly expressed. And T2 doing that for both of them. So you could get potentially 1 excellence point or 2 excellence points for this question. Okay, so that is the answer, and that concludes question 2.